Imaging systems. The pinhole camera is the simplest and most commonly used imaging system or camera model. It comprises a box with a small hole of the size of a pin. Every ray of light that enters the box must pass through one point. This simplifies the calculations of the projection of a point that is defined by XYZ in the three-dimensional space to the back of the box using simple trigonometry. The subscript P stands here for projection. Now, because this angle is the same as this angle, these ratios can be defined easily. XP over ZP is equal to X over Z. Similarly, YP over ZP is equal to Y over Z. And additionally, we know the depth of this box, and hence we can replace ZP with minus D. These are equations of simple perspective. The point XP, YP minus D is called the projection of the point XYZ. The field of view or angle of view of a camera is the angle made by the largest object that our camera can image on its film plane. Here we can actually calculate the angle of view. It is defined by this equation. Theta is equal to 2 tangent inverse h divided by 2d, where d is the distance of the imaging plane from the lens or the pinhole, and h is the height of the imaging plane. The ideal pinhole camera has an infinite depth of field. This means that everything in front of the camera is in focus. Doesn't matter where the light is coming from, it will always pass through one point and will hence be focused on the imaging plane. However, the pinhole camera has two disadvantages. It admits only a single ray from a point source, which means that almost no light enters the camera. The camera cannot be adjusted to have a different angle of view. It will always have a fixed angle of view. The human visual system is based on the three-color theory. Rather than determining the wavelength of light to find its color, it uses a simpler process. The human visual system has two types of sensors: the rods, which are monochromatic and are used for night vision, and the cones. The cones are color sensitive. There are three types of cones. Each cone is sensitive to a different wavelength of light, and they are basically centered at the red, green, and blue regions of light. These are three values, the tri-stimulus values, and these are the values that are sent to the brain, and our brain works out which color we are looking at. Hence, if we want to produce a color image, all we need to do is to match these primary colors. We can form different colors by using the additive model or the subtractive model. In additive colors, a color is formed by adding amounts of three primaries. These are used in CRTs, projection systems, or monitors, and so on. These primary colors are the red, the green, and blue, as shown here. Different combinations of red, green, and blue will produce different colors. Subtractive colors form a color by filtering white light with cyan, magenta, and yellow filters. These are used in light material interactions. They are also used in printing and in negative films. OpenGL uses the synthetic pinhole camera model. However, in this model, the object is projected upside down on the image plane. To overcome this problem, we put an imaginary image plane in front of the camera. With this synthetic camera model, the object is the right way up.